The year is 2049, and the world has undergone a renewable energy revolution. While fossil fuels are still used, they play a much smaller role compared to early in the 21st century. The transition began slowly in the 2010s, but rapidly accelerated in the 2030s and 2040s due to major breakthroughs in solar, wind, and energy storage technologies. The solar power breakthroughs started in the 2020s, with new high-efficiency solar cell designs that could convert over 50% of sunlight into electricity, far above the 20% efficiency of traditional silicon solar cells early in the century. New solar panel materials made from abundant, low-cost elements like iron, tin, and sulfur allowed mass production of these ultra-high-efficiency solar cells. Another key innovation was printable solar cell inks, that could be printed onto rolls of plastic film, enabling lightweight, flexible solar panels that could coat building surfaces, vehicle bodies, consumer gadgets, and more. Solar was no longer something just mounted on rooftops. It was integrated into the fabric of society. Installing solar became as easy as unrolling plastic sheeting, and it was cheap too. Between the high-efficiency cells and mass-production printing processes, solar PV electricity cost only a few cents per kilowatt-hour in ideal locations by 2030. At the same time, major improvements in wind turbine technology boosted the efficiency of wind farms. Larger turbines over 250 meters tall accessed stronger and steadier winds, while lightweight materials and advanced aerodynamic blade designs enabled these massive turbines to effectively capture that wind energy. Power electronics, storage systems, and AI management allowed wind farms to smooth out their intermittent power generation and sell stable output to the grid. Offshore wind really accelerated in the 2030s and 40s, led by floating turbine designs that opened up huge areas of offshore potential. Wind could now be generated consistently and affordably from the oceans, and started to seriously displace fossil fuel electricity generation. Onshore and offshore wind supplied over 30% of global electricity by 2040. With solar and wind both becoming so abundant and low cost, the priority shifted to energy storage. How could all this intermittent renewable energy be stored and discharged when needed? Old pumped hydro and lithium-ion battery storage continued improving, but two new technologies were game changers. The first was flow batteries. New material chemistries discovered in the late 2020s finally made flow battery storage commercially viable on a massive scale. Flow batteries used inexpensive, safe, and abundant elements like iron, salt, and carbon to store huge amounts of energy efficiently and cheaply. This enabled terawatt-scale renewable energy storage by the mid-2030s. The bigger innovation, though, was renewable methane production and storage. Around 2035, several companies commercialized power-to-gas systems that could use renewable electricity to split water into hydrogen and oxygen through electrolysis. The hydrogen could then be combined with waste carbon dioxide to synthesize renewable methane, the main component of natural gas. This renewable methane could be injected into existing natural gas pipeline networks and caverns for long-duration energy storage. No need for new special infrastructure. The natural gas system became a giant renewable energy battery. Renewable methane was also an ideal clean fuel for vehicles, ships, planes, and industry. The power-to-gas process became so efficient that renewable methane cost the same or less than traditionally extracted natural gas. Fossil fuels were being sustainably reinvented, and legacy energy companies shifted their business models accordingly. Green hydrogen also emerged as an emission-free fuel and chemical feedstock, enabling decarbonization of transportation and industry. By 2049, over 70% of the world's electricity comes from solar, wind, and other renewables. Affordable batteries and renewable methane provide days, weeks or even months of storage. The carbon intensity of grids has plummeted. Electricity powers a growing portion of transportation, while renewable methane fuels hard-to-electrify sectors. Carbon capture technology helps remove any remaining emissions at fossil fuel plants. The world reached peak oil back in the 2020s and peak natural gas by 2040. The transition has resuscitated economies, improved public health, and provided environmental benefits. Much work remains, but optimism is high, and the vision of a sustainable, renewable-powered future no longer seems a distant dream. The energy breakthroughs of the 2030s and 2040s were a crucial tipping point that will reverberate for centuries to come. What once seemed impossible is now simply the new normal. Subscribe